Yeah, hello. So in this video, I'm gonna talk about Leetcode problem 11 to 20. So from 10 problems, basically, we will learn some Leetcode patterns, and we're gonna use the patterns like for problem 11, we're gonna use the two pointers, and for 12 and 13, it is a basic mathematical problem. We just need to understand how to turn Roman to integer or turn integer to Roman. And 14 is a very simple string problem. And for problem 15, 18, and 16, they are quite similar. So we will solve it with a two-pointer pattern. So basically, we need to sort the array, and after sorting, and we just need to use the two pointers algorithm to solve the problem. And for problem 17, the backtracking is going to be the easiest way to solve. And for 19, it is a linked list problem. So we will use just one path to solve it. And for 20, it is a stack problem. We need to basically understand what is a stack and how to use the stack to do the basic operation and to solve the problem. Yeah. So for example, for Roman to integer, so we have the symbol. So this symbol, it is just 1, and this way is 5, and this x is 10, and we need to basically understand what is the meaning of all those characters. So basically, it is a k-value pair, and we're gonna use this kind of k-value pair to solve the problem. Basically, we need to store the k-value pair inside a dictionary, and similarly for this one, it is just a symbol with value. Yeah, and we need to understand how we can use such kind of a symbol with value to solve the problem. So for Leetcode problem 11, we need to check how can we hold most of the water. So it is always dependent on which bar is lower. So this bar is lower, so it means it's going to be this side. And then we just need to calculate the length. What is going to be the length? So by using two pointers, we can check it easily. So basically, two pointers, they're going to be different methods. Normally, it's going to be a left pointer and a right pointer. At the left side, we're going to set a left pointer. At the right side, we're going to set a right pointer. We just need to check if we can use such kind of two pointers to solve the problem. Yeah. So we need to check which bar is lower. If this bar is lower, so for the next step, we need to move this bar to the next bar, because only in this case it's gonna include all cases. Yeah. So for example, here we got a total area, and then if we move the normally, yeah, we must move the sorter bar. This bar is sorter. We're gonna move it to here, and then we're gonna calculate the area. Yeah, but we cannot move the higher bar. If this is a higher, if we move it, it's gonna miss something. Maybe after we move this sorter bar, maybe next bar is much more higher, so it means we can even hold more water, maybe. Yeah, but if you just shift the left bar, so we miss the opportunity to hold more water. So basically, this is how to understand the two pointers problem. So for problem 17, it is just how to dial a number. So for example, we have a string like 2, 3. It's gonna have how many different cases of the character. It can be something like AD or AE. Yeah, we can use backtracking. So from the beginning, it's gonna be empty, and then we're gonna have 3 bronze. It's gonna be A, B, C. So after this A, it's gonna have another 3 bronze because it goes to number 3. So it can be D, or it can be E, or it can be F. So this is the basic idea. So for the linked list problem, we need to check the last n nodes. So it means we're gonna count from the right to the left. So for example, this is 4 is the last two nodes. We're gonna count it from the right to the left. So n equals to 2. But how can we solve it by using two paths? So how can we solve it by using one path? So basically, if we were to solve it by using two paths, we can count. For one path, we just need to count how many nodes. So for example, it's going to be 5 nodes. And then from the right to left, it's going to be n equal to 2. So what about from the left to right? So we just need to do some mathematical calculation. So it's going to be 5 minus 2 plus 1. It's going to be this one. But for 5 minus 2, we're going to check the third node. This is the first, the second, and the third. And then it's going to be connected to node 5. So this is just two paths. But for one path, we just need to prepare a left pointer and a right pointer. So the distance between the left pointer and the right pointer is going to be 3. So this is the left pointer, this is the right pointer. So we're going to prepare, I'm going to call it a slow pointer, a fast pointer. So the fast pointer is going to be 4, and the slow pointer, this is the slow pointer, and this is the fast pointer. Yeah. So next we're going to move it. This is the slow pointer, this is the fast pointer. And next we're going to move it one step. And this is the fast pointer. So the fast pointer pointed to a noun. Yeah, this is a noun. And this is the slow pointer. So we're going to go out of the while loop. And this slow pointer going to point to its next and next. It's going to point to 5. So this is by using one path. We just need to keep a distance between slow pointer and fast pointer. So for each of the steps, we're going to keep the same distance. Yeah. Yeah, I think that's all about it. Basically, from problem 11 to 20, we're going to learn something. What is two pointers? Basically, we're going to prepare a left and a right pointer. And we will also learn some backtracking, how to use the backtrack to solve the problem. And we're going to also try to understand what is the stack. So for a stack, this is a stack. We can put any element 1, 2, 3 inside of the stack, and we can pop it out. Yeah, and we can use this stack property normally to check the brackets problem. Yeah. So for example, for the brackets, so if this is an open bracket, we're gonna put it inside of the stack. And next, if this is a closing bracket, we're gonna check what is on top of the stack. If it is open, we're gonna pop it out. And finally, we just need to check if the stack is empty. So this is for Leetcode problem 20. Yeah. So I think that's basically all about the problem. Now let's just start coding one by one to solve all those problems. Yeah. So container with most order. So for this problem, we're gonna use two pointers to solve it. As I said before, we're going to prepare left and right pointer, and I'm going to prepare a result as well. So this is going to be the right pointer, and the result I'm going to set it as 0. So if left less than the right, so let's just prepare AB as the left side, the height of the left side and the height of the right side, and we can check the maximum area. It's going to be the result, the minimum of the left and right bar times R minus L. Now we just need to check which one is lower. If the left side is lower, so L plus equal to 1, otherwise R minus equal to 1. And finally, we need to return the maximum area. Yeah, now let me just submit it to prove it works. Yeah, as you can see, it works. And the time complexity is O(n), because for this problem we don't need any kind of sorting. We just need to check it by using two pointers directly. And this is the optimal way to solve it. Yeah. Yeah, because if you don't use two pointers, you use the brute force, it's gonna be O(n) squared. But why two pointers works? Because it is always dependent on which one is lower. Yeah. Maybe you think, why? Maybe I need to include this case. This is lower. Maybe I want to include this case, the lower to this. Let me make a drawing. Yeah, so this one is lower. Maybe I want to include this case. Yeah, but this lowercase has already included from the beginning, and then we're gonna check this case. Yeah, we're gonna shift the lower. Maybe you're gonna think, oh, why not we just shift this one? But if we shift the higher one, it's gonna be here. This one gonna be a subset. So this one from here to here gonna be a subset from here to here. That is why we always shift the lower bar. Yeah, basically we need to check the lower bar. Now let's just move on to the next. So we need to turn integer to Roman. So this is the integer, and this is a Roman. Let's just check the first example. Yeah, I hope by reading the problem you need to understand what is the meaning of Roman to integer or integer to Roman. So this is a 3, and we have 3m. Definitely we have something to represent. It is a 3000, and then we need to find something to represent what is going to be 700. So it's going to be DCC, because D is 500, C is 100. So this is 700. Then we're going to find something to represent what is 40. Yeah, so XL is 40 because X is 10, L is 100. XL gonna represent 40. So this is gonna be 40. And then we're gonna check how to represent 9. IX is gonna be 9. Yeah. So basically this means if we are giving a number, we're gonna use, definitely it is possible. Definitely we can turn it to Roman numbers, and we just need to find a way how to turn it to Roman numbers. So definitely 3000 must be something M. Yeah. So we cannot use something like yeah, we have to use M to represent it gonna be 3000. So for each like 700, it must be DCC. It is not like 7C is 700. It's not like that. Yeah. So according to the information, actually this is some greedy idea. We're gonna always find the maximum number and then to the smaller number. So for example, 3749. We're gonna first find 3000 and then 700 and then 40 and then 9. So according to this way, we're gonna prepare two arrays to represent the symbol and the numbers from the biggest to the smallest numbers. Yeah, this is why we're gonna design the structure and the data structure. We're gonna use two arrays. So I'm gonna prepare a value. So this is gonna be a value array. So I'm gonna prepare the value from the maximum value to the minimum value. So after 1000, still it was possible. We have the 900. Yeah, because M is 1000 and CM is 900, and we have to find all those edge cases, even though we are giving like 1, 5, 10, but there's also something like 900. So we need to find such case. So it 500 and similarly 400, 100, 90, 50, 40, 10, 9, 5, 4, 1. Yeah, this is all the possible values. And at the same time, let's just copy the array. We need to find the symbols. What's going to be the symbol for all those values? Yeah, so basically it's going to be some string. So let me just copy and paste. So 5, 6, 7, 8, 9, 10, 13. Yeah, so we have such 13 cases to represent all the different cases. Yeah, so for the first one it is M, and then 900 CM, and 500 D, 400 CD, 100 C, 90 XC, 50 L, 40 XL, 10 x and 9 ix 5 v. We have to be careful, yeah. 4 iv and I. So that's gonna be all the possible cases. So if we didn't find all possible cases, definitely we're gonna make a mistake. Yeah. Now let's just prepare the final result. It's gonna be an empty string. So for any value and symbol inside the zip, we just zip them together. Zip the value and the symbol, and we can use the result to get all the possible cases. So it's going to be this num divided by the value. So for example, if it is 3000, 3000 divided by 1000, because the first value is 1000, so it is 3. So it's going to be 3m. So it's going to times this s. So s going to be a s going to be a string. So this string going to be m. Yeah. So after that, we need to remove that 3000. So it's going to be num modular the value. So this num modular value 1000. So what left behind is the 749. So we're gonna keep 749. So next, so the num gonna be reduced from this number to 749, and from 749 reduced to 49, and then to 9. Yeah, so this is what we're gonna check. So basically, we're gonna remove one number and remove another one and another one until we get the final result. Now let me just return the final result. Yeah, now let me just submit it to check if it works. As you can see, it works and it's pretty fast. And the time complexity is gonna be just the length of the value array or length of the symbol array. Basically, it's gonna be O(n) time complexity because it is the length is gonna be very short. Yeah. I think that's all about it. And similarly, we're gonna solve problem 13. 13 gonna be a little bit easier compared to 12 because we're gonna just turn them into integer. So this is easier because if we have I, because I is 1, so it's gonna be 3, and this is gonna be 58 because vi gonna be 8. Yeah. But what happens for iv? What about this case? So if there's something like iv, so it's gonna be 4. Yeah. So the idea is that we're gonna code it from the left to the right. I is 1, it is 1, and v is 6. We're gonna plus v is 5. We're gonna plus a 5. But of course, the 6 is not right because this is iv. This is not vi. If it is vi, it is okay. It is 6. But what happens if it is iv? It is 4. So we need to have a check. If the right, we need to check the two connected characters. We're gonna call iv is connected, or two neighbor characters. If this current character v value, if this character's value it is 5, it is bigger than the left side, and its left side this value is 1, because 5 is more than 1. So definitely we need to reduce this this number times 2. Reduce 1 times 2. So it's gonna be 6 minus 2. It's gonna be 4. So this is the idea. Because we plus the 2 marks. Normally we need to use minus, but currently we plus this one and plus this one. It means we plus this one 2 marks. So we need to reduce 2 times this one. This is why 1 times 2 for the solution. Yeah. So now let's just use this idea to solve the problem. Yeah. So we're gonna prepare a hash table. So this is gonna be yeah, all the possible cases. So this is going to be all the possible cases. We have the k-value pair. And this is going to be the value. Yeah, so let me just clean up a little bit about the dictionary. So basically it's going to be something like this. Yeah, we need to prepare such kind of dictionary for solving the problem. Yeah, because for the next, we just need to turn this row into integers. Yeah, we need to check all those possible characters inside the string one by one. So this is the first step. We're gonna build a dictionary, and after that, we're gonna prepare the final result. So the result is gonna be b as 0. So we're gonna take out the first character, because for the next loop, we're gonna check the second one. So for I in range 1 to length of the string. As always, we're gonna update the result by result plus d as I. So what happens if there's something like IV, it means, or VI. If it is something like VI, it is okay, but what if it's something like IV? It is not 6, it needs to minus 2. Yeah, so this means we need to have a check. So if d as I more than d as I minus 1, the previous one. So result gonna minus 2 times d as I minus 1. Now we need to get the final result. Yeah, now let me just submit it to check if it works. Yeah, as you can see, it passed for all testing cases, and it's pretty fast. The time complexity is n is less of the string. Yeah, so basically it is 15. It is a very small number. Now let's move on to the next. So let me just close. Yeah, let's move on to the next. So for this one, longest common prefix, we're going to use a very simple idea to solve the problem. Let's just prepare the one of the possible cases. So it's going to be string 0. Maybe this is a possible case because finally I'm going to return this result. So while there's something inside the result, it means this result is going to be a true or something. This is okay, or we can use a while true. It is also okay. Yeah. So I prefer to use a result. Yeah, because if something result is empty, I will not check it. I'm gonna return this result. I'm gonna return an empty string. Yeah, because I'm not sure about the testing cases. Maybe. Yeah. So I'm gonna use a while result. Then I'm gonna use all method in Python. So s dot starts with the result. This s is inside the strings array. Yeah. So for any string, if it is starts with the result, maybe it is starts with flower. Yeah. I'm gonna break it, and I'm gonna return the final result. Maybe it is a flower, but if it is not, I'm gonna reduce one character from the right to the left side. So I'm gonna reduce this character r. Yeah. If it is not, I'm gonna reduce it to check. So result gonna equal to, I'm gonna reduce the one character, and then I'm gonna reduce another one until I'm gonna reduce it to FL. Also FL is okay because all those strings are gonna start with the result because the current result is FL. So I'm gonna break it, I'm gonna return this FL. So this is the idea. Now let me just submit it. And this is not a best solution because the best solution gonna be using try, but that's gonna be an advanced data structure. I'm gonna prepare it in another video, but up to now it is okay to use this way to solve the problem. It is not, we are not using just 2 loops. It is not ON, it is n-cubic because s dot starts with is another ON. So this yeah, so for s inside of the strings, actually we are checking all possible word one by one. This is just a while check. It is okay. Yeah. But this O check, it introduces the time complexity by O(n), because we need to check all of them. And this starts with is another O(n), and this for loop is another O(n), so it's going to be n cubic, and this n going to be 200 according to the description. Yeah. So the time complexity is high, but the coding is easy. So up to now, I think it is okay by using this kind of idea. Now let me just move on to the next threesome. So we are going to check the sum of three numbers. If it is equal to 0, we're gonna get it and take it as the final result, but there's no duplicate. So for example, -1, 0, 1 is a possible case because -1 plus 0 plus 1 equal to 0, but there's no duplicate. We cannot have two of this kind of tuple. Yeah. So if we were to find all the possible triplets, it's going to be 3 for loops. It's going to be n cubic. N cubic, definitely it didn't work because n is 3000, so definitely it didn't work. So the idea is that what if we just use O(n) squared to solve the problem? So from the beginning we just sort the array, so it's going to be something like linear after sorting the array, and then we're going to take out one number, and if we take out one number, what's left behind is going to be two numbers. So for example, we take out this number. This number is 0. This number not 0. This number is -1. Yeah. If this number is -1 and we take it out, and this array is sorted, then we can use the two powders from the left hand to the right side. Yeah. Maybe the left side at this point is gonna be a 0. Maybe at the right side, maybe this is 5. Yeah. Normally 0 plus 5 should be 1, but it is 5. It is much bigger. So this means we cannot shift to the left side, because if we shift to the left side, maybe 0 becomes 1, 1 plus 5 is 6, it's going to become bigger. It is not possible. We have to shift to the right side. Yeah, so this is the idea. If it is bigger, we're going to shift to the right side until we find some value, maybe 1. So -1 plus 0 plus 1 going to be the possible result. So in this way, by sorting the array, it's going to be O log n time. And by using the method to solve the problem, we're going to use n squared. So the time complexity is going to be n squared, because we're going to use a for loop to take out each of the number, and then we're going to use two powders to find how many tuples, and we're going to put all those tuples inside a set just to make the problem a little bit easier. So first of all, we're going to sort it, and after sorting, I'm gonna prepare set it. Maybe I'm gonna prepare set and n. So s gonna be the set, because I need to remove all the duplicates, and n gonna be length of the nums. Now I'm gonna use the for loop to check all the possible cases. So here I will write it later, but I'm gonna prepare two powders first. So L are gonna be I plus 1 and n minus 1. So the two powder will be L less than R. L cannot equal to R because we need to find two other numbers. So this is the first number. We're gonna find two other numbers. It's gonna be at powder L and R. Yeah. So we're gonna prepare a variable total. It's gonna be the sum of three values. It's gonna be nums I, nums L, and nums R. Yeah. So if this value equal to 0, because according to the formula, it's going to be 0. So if it is equal to 0, we're going to get the final result. So we're going to put it inside a set, and it's going to be a tuple. Let's just copy those three values. And if we find a possible case, it means we can shift the left pointer and right pointer at the same time. So L gonna be plus equal to 1, and R gonna be minus equal to 1. Yeah. And if this total is 2 months, maybe. If it is maybe too small. If it is too small, we need to update the left pointer. Otherwise, we need to update the right pointer if it is too big. Yeah. So this is the basic idea. Let me just return on the final result. It's gonna be a list. We're gonna list this set. We're gonna turn this set into a list and get the final result. Yeah, maybe this works, but sometimes it didn't work. We have to speed up a little bit about this method. So let me just make a submit to check. Maybe, yeah, it didn't work. It is time limit exceeded because it happens for some testing case. Maybe it is always 0. Yeah, it's gonna have so many different cases. Yeah. So how can we reduce it? Yeah. So here I mean 3,000 times 3,000. It can be really slow. How can we reduce the time? We can reduce it from here by using this code. If I is more than 0, and if two neighbor numbers from this for loop, from the outer for loop, if this nums I equal to nums I minus 1, if the current number equals to the previous number, so we're gonna continue to check the next I. Yeah, because there's too many duplicates, we don't need to check it one by one. Yeah, let me just use an example. Maybe we have some numbers like -1, -1, 0, 1. So for this -1, we're gonna have a tuple like -1, 0, 1. Definitely, the sum of them is gonna be 0. But do we need to count this -1? No, because they are equal. We don't need it. Because for -1, if this -1 can find any kind of other two numbers, this -1 can also find other two numbers. Yeah. So this is why we're gonna avoid the duplicate by using this kind of line. Maybe you're gonna think, what if it is -1, -1, and 2? Yeah, we have 3 -1 and 2. What happens? For the first case, I'm gonna choose -1, -1, and 2. Yeah. But for the next, if it is equal, I don't need to choose this one because they are equal. If I choose it, it's gonna still be something like -1, -1, 2. It is a duplicate. This is why we're gonna use this kind of line to check. Yeah. Now let me just submit it to check if it works. Yeah, as you can see, at least it works because we speed up already. And the time complexity is going to be O(n squared). Now we're going to use the same code to solve other two problems because they are quite similar. So we're going to use it to solve Leetcode problem maybe 16. Yeah. And 18. So let's first go to the problem 16. Because for 16, it is just the 3 sum closest. We need to find the closest number. So we don't need a set. I'm going to prepare a result. From the beginning, I'm going to set it as infinity. It means it is not the closest. Yeah, so the coding is going to be very similar. So from here, this is total, but I don't need to check if that total going to equal to 0. I just need to check if it is close enough. Yeah. So if it is close enough to the target, yeah. If this total minus the target less than absolute value of the result minus target, it means this total is okay. I'm gonna set the total, so the result is gonna be updated to this total. Yeah. Then I don't need the elif and else. I just need to use if else. Yeah. So if this total is smaller than the target, I'm gonna set the left pointer +1. If it is more than target or equal to target, I'm gonna shift to the right pointer, because in this case definitely I'm gonna find all the possible cases. Yeah, because after the sorting, the nums will be in increasing order. I'm gonna find the closest. Yeah, so if I take out one number, and then what left behind from the left side and the right side, it's gonna be the total. It's gonna be the total of the three numbers. Yeah, because currently we are not sure if there's some equal case, if this one or equal. We just need to check if it is smaller. If it is smaller, it's gonna be one of the possible cases. But if this total is smaller than target, maybe this target is 3, but my total is 2. Yeah, so maybe I can find some total gonna be bigger. Maybe 2.5 is better than 2. 2.9 is better than 2. So definitely we don't have such digit float number. We only have integer, but it is okay. It is just an example. Maybe 3.1 is closer. Maybe 3.01 is even close. So this is why we're gonna need such kind of two pointers to check if we can find something even more closer. Now let me just return the result and have a check. Yeah, as you can see it works. Now let me just submit it. Yeah, as you can see it works, and I think the speed is okay. The time complexity is also O(n) square. Yeah, because the 3-sum closest is just similar to 3-sum, and we just need to change a little bit, and in this way we can find which one gonna be the closest. Definitely it is this total. We just needed to find all the possible total cases which is gonna be close to the target. And then for problem 18, as I said before, I just copied the code from the 3-sum and change a little bit, because this is just 4-sum. As always, we're gonna prepare 2 for loops. So for here, we're gonna prepare another for loop. So for j in range, it's gonna be I plus 1. And inside, we're gonna add nums j. So this is gonna be nums j as 4 numbers, and we are also giving a target. So we're gonna compare, instead of 0, we're gonna compare with the target. Yeah. Now let me just run it. Did I do something wrong? Yeah, because I forgot to change this one. Actually, this is j plus 1, not I, because this is the first number and this is the second number. And from here, I'm gonna use the 3-sum. So this is the 3-sum. I just need to add another for loop. Yeah. Now, as you can see, it works. Now let me just submit it to check if it can pass. Yeah, as you can see, it passed for all testing cases. Here the time complexity is going to be n cubic, and this is going to be a smaller value. It is just 200. That is why it works. Now let's just go back to problem 17, and this is going to be a good problem. Instead of using iteration, we're going to use a recursive function. Basically, we're going to use the backtracking to solve the problem, because it's going to be a little bit easier. We're going to define a hash table, and then we're going to use the hash table to solve the problem. Yeah. So 2 gonna be ABC. 3 gonna be value DEF. 4 gonna be JTI. Yeah. Let me just finish all of them. DKL 6 MNO 7. It's gonna be PQRS 8. It's gonna be TUV, and 9 it's gonna be WXYZ. Yeah, so this is gonna be the first step. We just need to check which number gonna represent which kind of character. So for example 2, it can be A, B, or C. Yeah. Now let's just define the backtrack function. Because I'm going to check the digits one by one, so I'm going to prepare index as I, and I'm going to prepare a temporary answer. So this answer is just a temporary answer. So if I equal to, let me prepare n going to be length of the digits, and the result is our final result. It's going to be an empty array, because I'm going to put all the possible cases. It's going to be answer inside of the result array. So if I equal to n, I need to check if this answer is not empty. I need to put the answer inside of the result, because according to my backtracking function, this answer can be empty. Yeah, I'm going to put the answer inside of the result. But anyway, if I equal to n, I want to have a return, because this is backtracking. We're gonna have a return to let it stop, to let the recursive function stop earlier. If we find one case, we're gonna return. Yeah. Otherwise, we're gonna execute the backtracking function. So for any character inside this digit, so it's gonna be D with digits, dictionary with digits I. We're going to execute the backtracking. It's going to be the next index, and it's going to be answer plus this character. Yeah. Now what are we going to do? What are we going to do? We just need to call the backtracking. It's going to starting from index 0, and the answer is going to be an empty string. Finally, we're going to return the result. Now let me just run it. Oh, I did something wrong. So what is the D? So for say, for any character inside the digit is I, two, 3, 4, 5. So digit size is 2. Yeah, let me print it out. Maybe I'm so what are going to be the digit size? So if it is a 2, so currently the digit size is a 2. So what about D2? What is wrong with D2? Yeah, I did something wrong, because it is not integer, it is a string. So let me just prepare the k-value pairs. So that is why it is k error, because the k is wrong. That is why it is called k error. So let me just fix it. Yeah. Now let me just run it. I think it's gonna be okay. Now we don't have the k error, and yeah, let me just submit it. Yeah. So as you can see, the backtracking, the coding for the backtracking is really clean, and it is also very simple compared with the iteration. We just need to prepare a very basic, simple backtracking function, and by calling this backtracking function, we're gonna directly get the final result. Yeah. So this is the Leetcode problem 17. Now we're gonna move on to the next. It's gonna be 19. Remove nth node from the end of list. Yeah. So this n means the last two node. It's gonna count from the right to the left. So we're gonna remove it from the end of the list. So if n equal to 2, we're gonna remove this one. It is this node 4. Yeah, as I said before, for this problem, we're gonna use two pointers to solve it. Yeah, it is a linked list, but actually, we're gonna use two pointers. So from the beginning, we're gonna prepare a dummy node. So this is a dummy node. We're gonna let this dummy node connected to the node 1. And then we're gonna prepare two pointers, the slow and faster pointer. So for example, this is a slow pointer. We're gonna put it here. And the faster pointer, because this n is just means a distance. This n equal to 2, so we're gonna make a distance to 3, because in this case we can directly get the final result. So from here, this is 1, 2, 3. So this is the faster pointer. This is the slow pointer. Then for each of the step, we're gonna move it. This is a faster, and this is a slow, and this is a faster, and this is a slow, and this is faster, and this is slow. We're gonna keep a distance. Because this faster pointer pointed to none, so we're gonna stop the while loop to check. And this 3 gonna be pointed to this node 5. Yeah. So this is the idea. So let me just prepare a dummy node gonna equal to slow and fast pointer. It's gonna be a list node. And the dummy node gonna be pointed to the header as well. Now I'm gonna use a for loop. I'm gonna keep a distance. I'm gonna check the distance. So for I in range n+1, I'm gonna move the fast. Gonna be equal to fast.next. Yeah. Now I have a distance of 3 for this example, because n equal to 2, 2 plus 1 is 3, 0, 1, 2. So I'm gonna have a distance from the slow to fast. It's gonna have a distance of 3. So I just need to check the fast pointer, and I'm gonna move the fast and slow at the same time. So slow, fast, gonna equal to slow dot next and fast dot next. Finally, I just needed to return dummy dot next. But before that, I needed to remove that node, because I've already found it, but I needed to remove it. So it's gonna be the slow dot next. Yeah, because currently slow is here. So slow dot next gonna equal to slow dot next dot next. Yeah, and finally I just needed to return dummy dot next. Yeah, I hope you like this kind of coding, because this is just one pass instead of using two pass. Because while we are using two pass, we need to count the total number of nodes. But by using one pass, we don't need to do that. We just need to fix it in one pass. So the idea is that we just need to keep a distance which is going to be n+1. Now let me just submit it to prove it works. Yeah, as you can see, now it works. And the time complexity gonna be O(n). And now let's just try to solve the last one. Yeah, as I said before, I'm gonna use a stack to solve it. So basically the idea is that we're gonna prepare an empty stack from the beginning. If there's any kind of a processes, for example, this is open, okay, this is open, I will put it inside of the stack. Now, if I find any current character which is a closed processes, I need to check if it is a pair. So if it is a pair, I'm gonna pop it out. So the stack gonna become empty. If it is empty, I'm gonna return true. So if it is not empty, it's gonna be false. So if stack add, the structure gonna be something or something or something, because there's 3 different kind of processes. Yeah, we're gonna have the brackets, the square brackets, or the curly brackets. Yeah, we just need to put it inside. If we meet the condition, we're gonna use the pop. Otherwise, yeah, we can directly append the character. Finally, we just need to return not stack. Now, let's just put the logic inside. Yeah, so what is the logic? It's gonna be stack -1 on top of the stack. It's gonna be it's gonna be open, and C gonna be close. Yeah. So in order to avoid making mistakes, let's just copy and paste and change a little bit, because in this way definitely we can avoid making any kind of mistakes. Yeah. So let's just change this one open, this one close, and curly open and curly close. Yeah. Now let me just run it and submit it. Yeah, as you can see, it's pretty fast because the time complexity is O(n). N is just the length of the string. It is 10 to the power of 4. Yeah. So basically, we finished all those problems. It can be, yeah, those problems, there's no hard problems. It is only easy and medium. So compared to the first 10 Leetcode problems, from Leetcode problem 11 to 20, it is a little bit easier, but we can learn more about it because there are more two-pointers problem. And for the backtracking, at least we can learn what is the basic pattern for the backtracking problem. Yeah. And for the linked list, actually this is also a two-pointer problem. We can turn it to a slow and fast pointer. Yeah. I think that's all about it. Thanks for watching. See you next time.